In this sequence of lessons, it's time to put our knowledge of passive solar homes into practice. Lesson 2.19 is all about answering the question, where is the sun in the sky? Students watch the Green Ninja video, Pie in the Sky, which uses a pizza to show a model for how the angle of the sun's rays change throughout the year. Students then use a flashlight to model the sun's angle at different times of day and throughout the year. Using their model, students discover that windows must be south-facing in order for thermal energy to transfer into the home. Finally, students visit a website to determine where's the sun going to be at different times of year where they live. In 2.20, students go back to that thermal mass investigation they did, and they create a list of materials that would be good for building a passive solar home. We then have a short presentation that walks students through using a sponge as an analogy for thermal mass. The sponge absorbs water, and it can hold a certain amount of water. However, there's a point where it can't hold anymore, and the water's leaking out of the sponge. Now, materials absorb and leak heat kind of similarly. We then introduce the criteria and constraints of our design competition to build a prototype passive solar home. Now, in preparation for that competition, we're going to review the engineering design process. In 2.21, we start with a problem that's designed to motivate students to answer what factors are a key in designing a passive solar home. We then discuss the rubric for their final passive solar home design report. Here's a short summary of the items on the rubric. Students then spend the remainder of class working in teams to design their prototypes. After a quick reminder that students must complete their prototypes during this class period, the only day, students get to work on and build their prototypes. In 2.23, students answer the question, how can we plan a fair test to see whose prototype works best? As a class, we come up with a consensus for the height and the angle of the lamp and how far away it should be placed from the prototype to come up with a completely fair test at different times of year for winter and summer. We then test our houses in the winter position. We start lesson 24 revisiting the report expectations and creating objectives for the class period. Students then test their prototypes using the summer position. They combine the results from everything onto an index card and display them alongside their models in a gallery walk. The goal here is that students are going to learn from other designs so they can propose ideas for improving their own prototype in the last section of their report. On the next day, students continue to review those classmate prototypes and also work on their reports, which are due tomorrow. We end class with the second concept checkpoint of the unit. Next up, we apply what we've learned to our school.